Welcome and namaste. Today we are going to learn about types of relation. But before starting types of relations, please once note that we are going to learn about types of relations on set A. What means relation on set A? First of all, we must be clear here. Relation on set A means a relation which is defined from set A to set A only. That means if each element of set A or any element of set A is mapped to element of set A itself, then the relation obtained is called the relation on A. And first type of relation is empty relation. Let us take an example. For example, A equal to 1, 2, 3 is a set. Suppose A equal to 1, 2, 3 be a set. Then if we find Cartesian product of set A to set A itself, that means A cross A, we'll get these 9 order pairs. As you know, Cartesian product of A cross A contains number of Cartesian product of A and A will be cardinal number of A into cardinal number of A, and it will be, there are 3 elements in set A, so we'll get 3 into 3 equal to 9 order pairs in A cross A. And if there are 9 order pairs and we suppose this Cartesian product as a set, we'll suppose this Cartesian product is as a set and each order pair in this Cartesian product is an element of this set. Here are 1, 1 is one of the element, 1, 2 is another element. Similarly, there are 9 elements in this set. And if there are 9 elements in the set, then how many subsets can we get? You already know. Number of possible subsets, or we can say possible number of subsets. Possible number of subsets equal to 2 to the power n, where this n is number of elements. How many elements are here? How many order pairs are here? Here are 9 order pairs. So it will be 2 to the power 9, and 2 to the power 9 equal to 512. We'll get 512 order pair, 512 subsets from this Cartesian product, and those all subsets are relations. You already know that relation is subset of Cartesian product. So here we'll get 512 different relations, but those relations are categorized in different types. One of them is empty relation. And if we suppose a relation R1 from A to A, that means relation R1 is defined on set A, then suppose R is equal to xy such that y equal to 4x. That means the second number of the element, second number of the order pair, second number of the order pair must be 4 times the first number. Is it possible? In these order pairs, in any order pair, is there second number, that is y component, 4 times greater than x component? 1, 1. 1, 2. 2 is not 4 times 1. 3 is not 4 times 1. 1 is not 4 times 1. Similarly, 3 is not 4 times 3. So this relation is not possible. That means there are not such order pairs in which second number is 4 times greater than first number. So this relation is defined, but there is no such order pair. So this type of relation is called empty relation. R1 is empty relation. So how to define empty relation? If no element of set Let's see this. If no element of set A is mapped to any element of set A, then the relation R on A is called empty relation. If there is a set A, elements of set A are 1, 2, 3, we have to find the relation between relation on set A in which second element is 4 times first element, then impossible, not possible. That is empty relation. Next type of relation is universal relation, or this universal relation is also known as full relation. Universal relation, also called full relation. Let's take an example for this also. Set A equal to 1, 2, 3 be a set, then Cartesian product will be again same. There are 9 elements in Cartesian product. And if a relation R2, if we suppose one more relation, that is R2, if this R2 contains all of the order pair of Cartesian product A cross A, then this relation is known as full relation, or you can say universal relation. Even universal relation can be more than this also, but on set A, we are discussing about the relation on set A, so this R2 will be universal relation. R2 is known as universal relation, or we can say full relation as well. Now let's see how to define it. A relation R on set A is a universal relation if each element of set A is related to every element of set A. That means there is set A, we have to find the relation on set A, elements of set A are 1, 2, 3. If each element of set A is connected to every element of set A itself, 1 is connected to 1 also, 2 also, 3 also, 2 is connected to 1 also, 2 also, 3 also, 3 is also connected to 1 also, 2 also, 3 also, then this type of relation is called universal relation, or we can say full relation. But universal relation and full relation, or universal relation and empty relation, are also called trivial relation also. Next type of relation is identity relation. What do you mean by identity? Suppose there is a set A, 1, 2, 3 be a set, and its Cartesian product will be same 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. And suppose there is a relation R3. Suppose a relation R3, 1, 1, 2, 2, 3, 3. 1 is mapped to 1 only, 2 is mapped to 2 only, 3 is mapped to 3 only. That means 1 is mapped to 1 only, 2 is mapped to 2 only, 3 is mapped to 3 only. This is R3. Each element of set A is related to itself only. 1 is mapped to 1 only, 2 is mapped to 2 only, 3 is mapped to 3 only. So this type of relation, R3 type of relations, are called identity relations. A relation I in which every element of set A is related to itself only is identity relation. And mathematically we write I equal to A for all A belong to A. Next is reflex relation. A relation on set A is called reflex relation. A relation on set A is called reflex relation if every element of set A maps to itself. every element of set A maps to itself. That means A is mapped to A belong to R for every A belong to capital A. Now let A is set 1, 2, 3, its Cartesian product are still same. Let us suppose R4, one more relation, R4. Here is 1 related to 1, 2 related to 2, 3 related to 3. There can be other elements also, but these elements, 1 related to 1, 2 related to 2, 3 related to 3, are present there. This type of relation is known as a reflex relation. Now your question will be, what is the difference in a reflex relation and identity relation? See, if in previous relation there was R3 equal to 1, 1, 2, 2, 3, 3. This relation is identity relation. There are only those order pairs in which one of the element is connected to same element. 1 is connected to 1 only, 2 is connected to 2 only, 3 is connected to 3 only. This is identity relation. But this R4, in R4, there are those order pairs also that is compulsory. There also that is compulsory. 1, 1, 2, 2, 3, 3 type of elements must be there. More than that, there may or may not be this type of elements, 1, 2, 2, 3, like this. Let's see the diagram. For reflex relation, 1 should be connected to 1, 2 should be connected to 2, 3 should be connected to 3. It's compulsory. But there can be 1, 2 also, there can be 1, 3 also, there can be 2, 1 also, there can be 2, 3 also, similarly 3, 1 also, there can be. But those are not compulsory. Compulsory are 1, 1, 2, 2, 3, 3. These elements must be there. Remaining elements may or may not be. So what is the difference between reflexive relation and identity relation? In identity relation, there must be only identity order pairs 1, 1, 2, 2, 3, 3. In reflex relations, there must be identity relations, that is compulsory. There must be identity order pairs, that is compulsory. But more than that, other elements also can be there. So R4 is reflexive as it contains all order pairs of form AA for all A belong to set A. Let's take one more example. 1, 1, 3, 3, this R5. Let's take R5. 1, 1, 3, 3, 1, 2, 2, 3. Is it reflexive or not? What do you think? 1, 1 is there. 3, 3 is there. But in set A, there is element 2 also. There should be 2, 2 also. But unfortunately, 2, 2 is not there. So R5 is not reflexive as it does not contain 2, 2. Now let's discuss about irreflexive relation. What do you mean by irreflexive? Is it opposite of reflexive? Okay, let's see. A relation on set A is called irreflexive if A does not belong to R. Other any element, any order pairs can be there, but A type of element, identity order pairs should not be there. Let's take an example, same example. Set A is 1, 2, 3. Then let's suppose R6, there is 1, 2, not 1, 1, not 2, 2. There is 1, 3, there is 2, 1, there is 2, 3. none of the order pair is identity there. So this type of relation is called irreflexive relation, and R6 is an irreflexive relation. For example, in a relation, there is not one. There is not one. There can be 1 to 1 can be mapped to 2, 1 can be mapped to 3, but 1 should not be mapped to 1 itself. 2 can be mapped with 1, 2 can be mapped with 3, but 2 should not be mapped with 2 itself. 3 can be mapped with 1, 3 can be mapped with 2, but 3 should not be mapped with 3 itself. Then it will be irreflexive relation. In case if 1 mapped to 1 also, 2 mapped to 2, 3 mapped to 3 also, then it will not remain irreflexive so far. Okay, now let's see next example, R7. In R7, there is 1, 1, 1, 3, 2, 1, 2, 3. Is it reflexive or not? Is it irreflexive or not? No, it is not irreflexive because there is one of the identity order pair, 1, 1. So it is not irreflexive. But that is not reflexive also. There is not 2, 2. There is not 2, 2. There is not 3, 3. So that is neither reflexive nor irreflexive.